Alright guys, so we're going to continue our unit on transformations, and we're going to talk about reflections and symmetry today. So anytime that we're discussing a reflection, we're going to be reflecting our pre-image across some line. So in this example here, we are reflecting across this x-axis. So we've got our pre-image here and then our image. So the image is always what the shape looks like after we've done the transformation. Same thing here, we've reflected our pre-image across the y-axis, and a reflection just flips that image over. Lastly, that reflection over the y equals x line, the y equals x line is going to go diagonally through your graph like this. So you're going to hit the point 1, 1, 2, 2, 3, 3, 4, 4, and the same thing in the negative direction. Alright, so let's do our first example. So we want to write the coordinates for the image, then graph both the pre-image and the image. I'm going to go ahead and graph my pre-image first. So I've got a point at -4, -5, a point at -2, -1, +2, -2, and +5, -5. So I've got this weird looking quadrilateral. And I want to reflect this over the x-axis. So I'm going to reflect it right across here because this is my x-axis. Okay, so I can, of course, apply these little tricks and use these. So if I reflect across the x-axis, my x and my y, they stay the same, but my sign changes on the y. So, for example, in this first point here, the x would stay exactly the same, and the y would just change the sign. So since the y was negative here, it becomes positive here. And we can do that for all of our points. I personally, if this is a -4, +5, personally think it's easier to count from my pre-image point to my line of reflection and then go the same way on the opposite side of that line of reflection. So both sides are going to be symmetrical. So let's see, 1, 2, 3, 4, 5 to that line of reflection, and then we're going to go 5 in this direction. So 1, 2, 3, 4, 5. So you can see it's the same distance. So for example, if we start at this point, we are one little hop away, so we're going to be one hop away on the other side. Here, 1, 2, so 1, 2. And then lastly, we are 5 away, so we will be 5 away here as well. Alright, so that is our image after we've reflected it across this line, the x-axis. So my points are -2, 1, 2, 2, and 5, 5. Alright. So let's look at the next example, where this time we're going to be reflecting across the y equals x line. So that y equals x line is actually going to go straight through here. And like I said, it's going to hit 1, 1, 2, 2, 3, 3, 4, 4, and the same thing in the opposite direction. Whatever x equals, y is going to equal the same thing. All right. So let's look at our pre-image and graph that. So I'm going to graph our pre-image in purple. So we've got a point at 1, 0, a point at 3, -4, and a point at 1, -4. Alright, so we've got this little baby triangle, and we're going to reflect it across this line. So it's going to kind of go that way. So it's going to point in this direction. Okay, so let's look at our points here. So do you see if I'm going diagonally towards this line, I'm going from this intersection at 1, 0, I go diagonally a halfway across that block. So I'm going to go halfway across on the other side. So then down here, I'm going a full cube, so that's 1, then a full 1, so that's 2, and then half. So I'm going to go 2.5 on the other side. So there's my half, 1, and 2. Same thing with this last point. I'm going to go a full diagonal little square or box, and then the second one, third, and then a half. So then I go one, or half, 1, 2, 3. And there is my image. So my points for the image are 0, 1, -4, 1, and -4, +3. So we can count across and just reflect it across this line if you're okay with that. If you prefer to use these points, these little formulas or cheat sheets, whatever you want to call them, up here at the top, that's fine too. If you can see that when we reflect over y equals x, that the x and the y just flip. And if you look down here in this example, the x and the y just flipped. What was here the x was 1, so then 1 becomes the y, and the 0 was the y here, so in the image after the reflection the 0 goes in the x spot. So whichever way you prefer, I'm fine with, just so long as you know what you're doing. Alright, so let's go to the next example. So we're going to look at these figures and use this grid to answer all of these questions below. So the first one says, which figure is the reflection of figure A over the y-axis? So the y-axis is right here. And we want to know which figure here is going to be a reflection over this line of A. So like I said, I like to kind of count over from a point to the line of reflection. So I've got 1, 2, 3, 4 little hops I'd have to make in order to get over to that line. So I'm going to go 4 in the opposite direction. So 1, 2, 3, and 4. So that means C is going to be my reflected figure. For question 2, it's asking which two figures have x equals -3 as their line of reflection. So if we've got a x equals -3, that's going to be a vertical line. It's going to be right here. And I'm going to label this. So we want to know which two figures have been reflected across this line. So you can see that F and G are just the flipped images of each other. So we're going to put that down as our, I'm sorry, not F and G, E and F. Alright, so 3. Which figure is the reflection of figure A over the line y equals x? So y equals x, again, is that line that goes right through our origin, and then whatever x equals, y equals also. So that is the line y equals x. So I'm looking to see which figure is a reflection of A. So if I'm pointing in that direction here, when I flip it over, I'm going to be pointing, that pointy smaller part up here is going to be pointing in that lower direction. So it's going to be figure H. Alright, so 4 is asking us to find the equation of a line for figures G and H to be reflected across. So you can see that if we want these 2 points, since those 2 points are reflections, if we want those to be equally distant from the line of reflection, our line's going to have to go right in between the 2 of them. So that is a horizontal line, so it's going to be y equals, and then it's right in between the -4 and the -5, so it's -4.5. Alright, and then lastly, which figures are not reflections of figure A at all? Or, I'm sorry, name all. So we can see that figure A is going to be a reflection of, figure B is going to be a reflection of A across a reflection line somewhere around there. So B is, we already said C is in question 1. Let's look down at D. Would D be a reflection? Is there any way that we could flip that over to get to this image here? No. So D is actually going to be something that we talked about in the last lesson, and that is a translation. We just took A and we slid it down to a new location on the graph, and when we move our figures up and down and left and right, that's a translation. It's just a slide. So D is not a reflection. Let's look at E. Could E be a reflection if we reflected across a line somewhere in here? Absolutely, yeah. E could be a reflection of A. F. Could F be a reflection of A? Well, no. Because if it was a reflection this side of the triangle, or actually let's use our hypotenuse. Our hypotenuse of the triangle would still be on the bottom. And if you can see, F has the hypotenuse on the top. So it looks more like some sort of a rotation rather than a reflection. All right. So the next one we're going to look at is G. So G also looks like it's some sort of a reflection, and not some sort of a rotation, not a reflection. And then H definitely is a reflection. We said that it was in question number 3. Okay, so let's move on to symmetry. Symmetry is something you're probably familiar with. Something being symmetrical means that it's the same on one side as it is on the other. So, for example, when we fold paper in half and we get that crease in our paper, that crease is our line of symmetry. This half of my page is the same as this half of my page. So this is a really great example of how we were familiar with that line of symmetry and we didn't even realize it yet. Okay, so if we look at this first example, we've got a line of symmetry right here, because if we took this left-hand side and folded it along that dotted line, it would fold nice and neatly on top of this right-hand side. Same thing with the bottom. If we folded it up, it would lay perfectly right on top of this top portion of our figure. And sometimes figures can have no symmetry, and then sometimes they can have a whole bunch of symmetry. So it's really just, it's up to each shape that you're looking at. You just have to be very careful. All right, so let's look at the first example. Our first example, if we were to do a vertical line, could we have symmetry? If we folded it, this point would not line up perfectly on this side. So this is not going to have a vertical lines of symmetry, but it would have a horizontal line of symmetry. You can see that if I folded it right along this line, that this top part would lay perfectly flat on this side over here. Alright, so this has one line. And then let's look at example 2. So example 2, I can't do a vertical or a horizontal line of symmetry. And the reason for that is because my corners are not going to match up. So you can see if I took this bottom part and I folded it up, it would actually sit like that, and that wouldn't be identical. So then I can't do a line of symmetry here or this way. But I could do a line of symmetry diagonally, assuming I can draw straight diagonal lines. There we go. So I can do 2 lines of symmetry for this one. All right. So lastly, a figure can have rotational symmetry. So if it can be turned 0 to 180 degrees and the figure looks exactly the same as when it started, then that however many degrees you rotated your figure is called the angle of rotation. So for example, if I have this figure here and I rotate it 90 degrees, I end up with a figure that looks exactly like it did when I started. So I can actually do that 4 times. So I can do it here, second time, third time, and a 4th time. So I can go, there's 1, 2, 3, and then 4. So in order to find out that the figure has the angle of rotational symmetry of 90, I would do 360 divided by the number of times that image looks exactly the same as when it started. So we were able to do it 4 times. So 360 divided by 4 is 90. So that's where that angle of rotational symmetry comes from. So let's look at this example here, number 3. If I've got my point here where I'm rotating from in the center. I'm going to rotate around, so obviously I'm starting off 1. Then I'm going to rotate again. It looks exactly the same a second time. And then again, all the way around a third time it looks the same. And then back to my original. So 3 times I was able to rotate it around and it looked exactly the same as it does right now. Alright, so 36 divided by 3 is 120 degrees. 120 degree angle of rotation. Okay. So then let's talk about this last example right here. So on example 4, if I'm spinning this around, I've got this kind of little leg that kicks out right here, so I have to be cautious of that. No matter how I turn this, that little leg never sits right back in this location unless it's in its original place. So since I can't turn it a certain number of times other than its original spot to get that little leg back here, I'm going to have no rotational symmetry. Rotational. Okay, guys. All right, if you have any questions, let me know. Thanks.